All right, moving on, we're asked the same sort of question. We're just not given a triangle. So what I would suggest starting with here is draw your own. So we know this is a right angle triangle, and I'm lucky enough to be able to make mine perfect, but it doesn't have to be in your drawing. Angle C is 90 degrees. Angle A is 16 degrees. And, okay, we don't know angle B. Little b, though, is 92. And we're asked to solve this triangle. So let's make this side little c and this little a. Okay, so let's start by finding angle B, because we know angle A plus angle B equals 90 degrees. And angle A was given to us at 16 degrees. So we can subtract 16 from both sides. And we get angle B is 90 minus 16, which is 74, I think. Yes, 74 degrees. Okay, let's move on to our side lengths now. So we need little a. Let's think of this triangle relative to our known angle 16. So little a would be my opposite side, and little b is the adjacent. So let's use the tan ratio. So we know tan of any angle is opposite over adjacent. So tan of 16 degrees is little a over 92. Let's multiply both sides by 92. And we can calculate that. So 92 times 1016 gives us, out to one decimal place, would be 26.4. Okay. And the only thing left we have to solve is C. We could do that with Pythagorean theorem, or we could do that with cosine. Let's use Pythagorean theorem. I'm just going to store this number from A on my calculator, but if it's easier, write down a few more decimal places there so that you have a more precise estimate of that length. And so we know a squared plus b squared equals c squared, and we're looking for c. So a we found to be 26.380575, or again, just keep that stored on your calculator, plus b, which is 92 squared, and that equals c squared. So when we type that in, I get 9,159.9347. And then we're going to square root both sides to solve for c. And to one decimal place, that gives me 95.7. Okay, let's do another one like this. So again, we're given a triangle with a right angle. So I'm going to draw myself a right angle triangle here. Angle C is 90. And we don't know angle A or B, but we know little a is 1, and little b is also 1. So let's start by finding C. So a squared plus b squared equals c squared. A and b are both 1. So c squared is 2. And so let's square root both sides. And we get c is 1.4. And now let's solve for some angles. So let's start with angle A. So we're looking for angle A, so that's our target angle. Relative to angle A, we know our opposite and our adjacent. So let's use the tan ratio. So tan of any angle theta is opposite over adjacent. So tan of angle A is 1 over 1, which is just going to be 1. And so to solve for angle A, we're going to take the tan inverse of 1. And if you take the tan inverse of 1, you'll get 45 degrees. And now to solve for angle B, we can use the property we know angle B plus angle A has to equal 90. And we just found that angle A was 45 degrees. So angle B then is going to be 90 minus 45, which gives us 45 degrees. And we've solved everything there. Okay. In this one, it tells us triangle ACB is angle ACB, so which is the same as angle C right here, is 90 degrees, denoted by that little square there. Angle A is 60, and altitude CD is 12. So they've written all that down for us. First of all, they want us to find angle B. All right, so we're looking for this here. And so let's consider the triangle on the right. Oh yeah, actually, let's consider the entire triangle, the big triangle. So if I consider the big triangle, like triangle ABC, then I can see that angle A plus angle B has to equal 90 degrees because it's part of a right triangle. And angle A is 60 degrees. So if I subtract 60 from both sides, I get angle B is 90 minus 60, which gives me 30 degrees. So that was part A. Okay, part B. We're asked for line segment AC. Okay, and I kind of hate calling it line segment AC, so I'm going to call it X. Okay. How are we going to figure out that? Well, we know over here we have a right angle, which means we have a right angle on this side too, since the two form a straight line. So if we consider the smaller right-handed triangle on the left, we can think about the 60 degrees here. Relative to that 60 degrees, the 12 is my opposite side, and the x I'm trying to find is my hypotenuse. So let's use a ratio involving opposite and hypotenuse, which is sine. So sine of any angle theta is opposite over hypotenuse. So sine of our angle 60 degrees is 12 over x. And so let's multiply both sides by x to get it out of the denominator. And now I have x times sine 60 equals 12. And now let's divide both sides by sine 60. And so I get x is 12 divided by sine 60, which out to 1 decimal place is 13.9, and I'm just going to write that's the same as line segment AC. Okay. Let's go on to C. So now we're looking for line segment BC. So B to C, I'm going to call that Y. Okay. Well, I think we're going to have to know the fact that angle B, we're going to have to use that we know that that is 30 degrees and consider the right angle triangle on the right-hand side there. Relative to that 30 degrees, maybe I'll just erase this opposite and hypotenuse from earlier. So relative to that 30 degrees, the 12 is my opposite side, and the y is my hypotenuse. So we can once again use the sine ratio. So sine of 30 degrees is 12 over y. Multiply both sides by y. And then let's divide both sides by sine 30. So I get y is 12 divided by sine 30, which gives me 24. Okay. And last one. Oh, and maybe I'll just write y is actually line segment BC. I just don't like writing BC over and over again. Okay. Okay. Last one, we're asked for line segment AB. Okay. Well, relative to that 60 degrees, let me erase what we wrote earlier. Now thinking relative to the 60, if I consider this the big triangle, then y is my opposite. I know y now is 24. And AB, let's call that Z. And that would be my hypotenuse. So I need a ratio. Geez, we've used sine a lot today with the opposite and hypotenuse. And that's going to be sine. So sine is opposite over hypotenuse. I suppose I also could use Pythagorean theorem here, couldn't I? Let's do that because it'll add some variety to our sine ratios. Okay, so we know the two legs of the triangle adds to the hypotenuse. So in this case, x squared plus y squared equals what I've labeled as z squared. So x was 13.9. I didn't save that number in my calculator, so we'll have to just estimate it. So 13.9 plus 20 squared plus 24 squared equals z squared. And that gives me 769.21. And let's take the square root of both sides. And I get to 1 decimal place 27.7. And that is AB. Okay. Last question. We have an airplane flying 300 kilometers at a heading of 80 degrees. So they've shown us a picture of what that looks like here. How far north and how far east has it traveled? Okay, well, if that's 80 degrees, then I know this other angle has to add, the two angles have to add up to 90 since north and east are perpendicular to one another. So they're a right angle. So that little angle there must be 10 degrees then, 90 minus 80. Okay, and it wants to know how far east, I'm going to call that x, and how far north, and I'm going to call that y. So relative to that 10 degrees, y is my opposite side, x is my adjacent, and the 300 would be my hypotenuse. So let's start by figuring out x. So x, I need a ratio involving adjacent and hypotenuse, so I'm going to use cosine. So cosine of any angle is adjacent over hypotenuse. So cosine of 10 degrees is x over 300. And let's multiply both sides by 300. And so 300 times cosine 10 gives me 295.4 if I round to the nearest tenth. And we have units that is in kilometers. Okay, now let's figure out y. So to figure out y, I could either use sine ratio or I could use Pythagorean theorem. I'm going to use Pythagorean theorem. So I know the two legs of the triangle, which we typically call a squared or a and b, are equal to the hypotenuse c. So in this case then, x squared plus y squared equals my hypotenuse, so 300 squared. And I know x from up above. I'm just going to leave that whole number stored on my calculator, but 295.4 squared plus y squared equals 300 squared. So we're going to subtract 295.4 squared from both sides. And so y squared is going to be 300 squared minus 295.4 squared. And that gives me 2,713.832 or so on. And then I'm going to square root both sides. Which gives me, to the nearest tenth, 52.1 kilometers. So it's a word problem. Let's give a word answer then. So it traveled 295.4. Oh dear. Oh, it missed the 9. Let's try again. 295.4 kilometers east. And 52.1 kilometers north. And that's it.